So we're looking today at solving two-step equations. Hopefully you still have your foldable from yesterday. Yesterday we did solving two-step equations, and just to kind of briefly review, first of all, we're using all four types of operations: plus, minus, times, divide. We're undoing things, which means we go backwards, reverse order. So this is what we mean. Scrap. We mean that whatever we're doing, we're undoing things. So, for example, if you have x minus 2 equals 10, not too hard of a problem, right? You might say, okay, to undo subtraction, I do addition. So you add 2 to both sides, and those cancel, and we get x left over, and we get 12. Now that wasn't too bad, right? Or then maybe think about the other type of problem we did. Let's say 3 times y, we'll use y this time, equals, say, 12. Now again, we do the opposite. To undo timesing, we divided both sides. And that way the 3's got canceled. And we're left with y equals 12 divided by 3 is 4. Now those were two different problems that we did yesterday, okay? Or kind of in the past couple of days. But we're going to try a different type of problem today. What if you combine the two together? Let's say it's 3z, or z. We're going to have 3z minus 2 equals 16. We changed the numbers around a little bit, but you notice we still have the minus, we still have the times. I didn't put it in there, but there's a times there. So now we have two things to worry about. But here's why this works. Back in these other problems, even though this was timesing, we didn't multiply anything, did we? We divided. We did the opposite. It's actually called the inverse of whatever was given. So we're kind of getting that mode. Think about opposites, inverses. Now, normally we would do, please excuse my dear Aunt Sally. So step 1, step 2, step 3, step 4. That's normal. When you're figuring out a problem or something, you have multiplication, you have subtraction, you have parentheses. You always go in that order. But we're not just figuring out a problem, we're trying to undo things. So just like over here, normally you times those two. But to undo it, we did the opposite. So even though normally we would go in this order, to undo it, we're going to go the opposite order. We're going to start at addition, subtraction, and go backwards. So we want to undo the subtraction that we have there first. So what's the opposite of minusing 2? It's plusing 2. Now we just did that up top. Different numbers, right? But we just did that. Same kind of idea. So these cancel. We're left with just 3z over there, 3 times z, I should say. And we get 18 over here. And now maybe you can do it in your head. Maybe you could to start with. And now we have timesing. That's our next step, going reverse sort of operations. So you see how we did the same steps? These cancel out. And we get 6. See how we did the same steps as when we had these simpler problems? The difference is we're putting them together. So the only change is we have to know what order to go in. You have to know what to undo first. That's where this order of operations comes into play. So that's just kind of our little introduction. Don't forget, by the way, whenever you get an answer, to check it by plugging it in. And that's kind of, if you can do it in your head, that's where doing it in your head helps, because you don't really have to check it then. You've already done it in your head. So I'm going to try and zoom in a bit here. Hopefully, it's hard for me to see the camera. Hopefully that's big enough for you. Of course, you guys can always bump it to full screen. But first of all, what does solving mean? We've been solving for a little while. What do all your answers look like? Like the one we just got. All three of those answers, we have a letter equals a number. Letter equals number. Letter equals number. Now it can be flipped. It could have been 12 equals x instead of x equals 12. But solving means we end up with just the variable, the letter, all by itself. So we're going to say solving means that you isolate the variable, which means you get it by itself. It's all alone. So we want the variable all by itself. For example, let's use, how about k? K equals 5, right? Or 7, let's make it -7 equals y, or whatever. But the variable's by itself. That's the goal, to get everything else to the other side. Okay. So order of operations, if you remember, we had parentheses, exponents, multiplication and division, addition and subtraction. Now that's good for order of operations, but we're not really using order of operations. When we solve, when we want to get these variables by itself, we don't use order of operations. We use the opposite. So we're going to say the reverse order of operations. So that means step 1 is actually going to be, and I'm going to use symbols this time, add and subtract. Step 2 is going to be times and divide, multiply and divide. Step 3 will be exponents. However, write it down, but I will tell you I haven't seen any exponents in this whole chapter. We'll do them someday. They will get there. And lastly, we do parentheses. And I kind of like, because I'm a visual person, I like to put parentheses in parentheses. So we have adding, subtracting, multiplying, dividing, exponents, parentheses. So that's kind of the order we're going to go in. Now, the fractions one down here, we're going to get to that in a minute. But let's try an example first. So pull up to this first example. We're on the top right, and we notice we have a few things going on. We have an adding, and we have a times. Right? That means 7 times x. Put the little dot in if you need it. Okay. So which one are we going to undo first? Well, reverse order of operations, we get rid of all addition and subtraction. So we're going to start with this plus 18. So how do we get rid of a plus 18? Well, we would want to do the opposite, which is minus 18. Now that's good, and hopefully you realize that they cancel out over there. But what did I forget? If we're minusing 18 over here, we also have to minus 18 over here. Now when we do that, these do cancel out, which is great. We might say, well, if they cancel, that means 7x is the only thing left, which is true. And how about over here? Negative 24 minus 18. I'm going to draw a little number line to help me. So here's 0. I'm not going to put all the numbers in, but here's negative 24. Right? Now, I'm going to minus 18. Well, you can't quite see that number line. So I'm going to minus 18, which means I'm going to go even farther to the left. We're going to go back 18. Or think of it another way. I'm at $24 in debt. I owe someone 24 bucks. But then I lose another 18. I owe them another 18. So off to the side here, I believe the method for doing that was actually to add them. I do that, 2, 3, 4, I get 42. Now that's nice, but 24 and 18 is not just is 42, but in our problem, what do we need to include? It was negative 24, and I lost another $18. That means it's a total of negative $42. So there's our first step. Order of operations, we've done the addition and subtraction, there's none of it left. Now we go on to timesing and dividing. So we do have some timesing. We have this one that's 7 times x. How do I undo 7 times x? I divide by 7. And if I do, the 7's cancel, which is what we want. Cancel them. And all we have left is an x. Remember to do that 7 to both sides. Well, what is 42 divided by 7? Just do the number part first. I think we get 6. Check a calculator, check your multiplication tables. Hopefully you're starting to get those better than maybe at the beginning of the year. Well, what about the negatives? We have 1 negative and 1 positive. We know that gets us a negative answer. Remember, 2 negatives would have made it positive. But since there's only 1, it stays negative. Now, circle your answer, because it's kind of hard to spot sometimes, and then plug it in. And you can do the plugging in your head sometimes. Plug it in. 7 times negative 6, negative 42, plus 18, do we get negative 24? And I think we do, but we need to check. Okay, now skip down to this one that has the fraction, right? We have k divided by negative 3 minus 11 equals negative 20. Really hard to do in your head. Okay, I'm not saying can't be done, but really, really hard. First of all, this is bothering me. I'll put a boundary in there. Now, for fractions, here's what we have to do. Okay, this kind of fraction is pretty, straightforward. But down here in the fractions part, we're going to put one thing first. For fractions, we're going to put in parentheses. It means division. It means divide. Fractions mean divide. So when I see up here, k divided by negative 3, oops, hold on. When I see up here, k over negative 3, that means that we're dividing. So go back to our steps, right? We're going to do adding and subtracting first. Since this one's dividing, we want to worry about that later. First, we have to get rid of this negative 11. So what's the opposite of minusing 11? Is to add 11. If I add 11, the 11s cancel out, right, which is good. But what do I have to do to the other side? Also add 11. So what do we have left? K over negative 3. Okay? How about the right side? Negative 20 plus 11. Now, if I follow my rules, I think negative 20 plus 11, I'm actually going to subtract and find the difference. Now, if you remember, our rule for knowing if it was positive or negative is to say, well, which one's bigger, the positive number or the negative? And the negative's bigger, so it makes that one negative. Now, here's another way to think about it. You're at negative $20. You owe someone 20 bucks, and then you find $11 in the street. Now, you got to give it back to the person because you owe them money, but you now owe them only $9 instead of 20. So you're moving up in the world. Also, of course, we could use a number line. At negative 20, maybe here's 0. We're going to add 11. So we're going to be closer to 0. Now back here, what's our next step though? Well, we're dividing by negative 3. So what's the opposite of dividing is to multiply. So we're going to multiply by negative 3. Both sides, right? Now if you times the left side by negative 3, the negative 3's cancel. And we have left k. How about the right side? We have 9 times 3 is 27. A negative and a negative is a positive. And don't forget, again, when you're done, to go ahead and plug it back in. Now that fraction was simple because it only had, I shouldn't say simple, that makes it sound like it's easy. What I mean is it's a simple style fraction in that there's one thing on the top, one thing on the bottom, right? It's just a k on the top, negative 3 on the bottom. By the way, remember what the top is called? The numerator, and the bottom is called the denominator. So we have one thing in the numerator, one thing in the denominator. Now you notice in our next problem we have two things in the numerator. So we're in a complex fraction. And it is going to be a little bit harder to deal with. Slide over to your notes part on the left. And for fractions, we know it means divide. But we're also going to say put parentheses around the top numerator if there's more than one thing. So if there's more than one thing up there, we want to put parentheses. For example, this one, no parentheses needed. Why? Because how many things are in the top of the fraction? Just one. But this one, we put parentheses up there. I might say, well, that doesn't really do a whole lot, does it, Mr. Stevenson? Well, it does, and here's why. Because go back to our order. Remember, we're going to start with addition, subtraction, times dividing, exponents. Parentheses will be your last step. So this one here will be our last step. That is crucial. So when I go over here, the first thing I'm going to do is put the top in parentheses. So I remember. So I'll remember. That's right. That top's in parentheses. I don't want to do it yet. So when we do our order of operations, reverse order of operations, we do the adding and subtracting first. But we can't do that adding. Why not? Well, we can't do it because it's in the parentheses, right? So we need to worry about the next step, which is times and dividing. We don't have any adding and subtracting. That's a parenthesis. So we worry about the divide by 7. So what's the opposite of dividing fraction? Dividing by 7. The opposite is to times by 7. So we're going to times both sides by 7. Now these two 7s cancel. Always times both sides. What's left is the b plus 4. And 3 times 7 is 21. There's one negative, so we make it negative. Now, why didn't I put the parentheses in this next spot? Well, do you need them? If there's nothing else there, do the parentheses even do anything? No. So go back to our order of operations. We've done addition and subtraction. There actually wasn't any. We did the multiplication division, no exponents. We're now in the parentheses step. So whatever happens to be inside the parentheses, that's what we're going to be doing. Okay? So we're going to minus 4 from from both sides, because that's the opposite of adding